Today we're going to talk about the last two theorems of circles. So the first one we're going to talk about is the congruent chord theorem. So the congruent chord theorem tells me the following. If two chords are congruent, then two things happen. So if two chords are congruent, then two things are going to happen. The first thing that happens is when two chords are congruent, the corresponding arc measures are also congruent. So when two chords are congruent, the corresponding arc measures are also congruent. So if I draw the circle, and here's my center, and I draw any two chords that I want. Here are my chords. If those chords are congruent, then its corresponding arcs, which is this arc and this arc, they're congruent as well. So that's what number one tells me. Number two tells me when two chords are congruent, then the center is equidistant to both chords. Equidistance just means it's the equal distance. So if I look at this picture, here's my center. The distance between my center and this first chord is the same distance as the distance between this center and this chord. So if I draw it, all it's saying is this distance and this distance are the same. So let's go ahead and let's look at some of these examples. The first three examples say find the chord length. So it gave you the arc measure. So if I look at number one, I see that this arc measures 155 and this arc measures 155. So I see that those arc measures are congruent, which means their corresponding chords are also congruent. So if CD is 9, then I know AB is also 9. If I look over at number two, I see the tick marks through this arc and this arc, so that means they're congruent, which means their corresponding chords are congruent. So it wants what FG is, so FG equals 6 because EG was 6. If I go over and I look at number three, I see this arc and this arc are congruent, and obviously this chord corresponds to this arc, and this chord corresponds to this arc. Since they both use this piece in common, you can assume that's just congruent with itself. So now notice they have the same tick marks. So the length of this chord is 8, because 3 plus 5 is 8. So Km equals 8. So now, let's go ahead and find the arc length of these ones. So notice here on these ones, I see this and this are congruent, which means the corresponding arcs are congruent. So WZ is 105, so XY is also 105 degrees. If I look at number 5, notice 85 degrees is a central angle, which means this arc is 85 degrees. So since this arc is 85 degrees, I can assume this arc TU is also 85 degrees, since its corresponding chords are congruent. So go ahead and pause this video and try number 6 on your own. When you finish, unpause the video and I'll explain. So you know this arc is 100. And you know this arc and this arc must be congruent because their corresponding chords are congruent. So since all arcs add up to equal 360, I would do 360 minus 100, which is 260. And then I'm just going to divide that by 2 to figure out what one of them equals. So arc AB is 130 degrees. Go ahead and flip your paper. last property we have to discuss is not actually called the chord theorem. We're going to call this the perpendicular chord theorem. So if you could write the word perpendicular chord theorem. So what this theorem tells me is if a chord is perpendicular to the radius or diameter, then the chord is bisected. If a chord is perpendicular to the radius or the diameter, then the chord is bisected. So the word bisected means what? Well, it means that they're cut into two equal pieces. They're congruent. It's cut in half. So if you look at this picture, here's my diameter. Here's my chord. Sorry, my dog's growling in the background. Notice my diameter is perpendicular to my chord. And now notice AB and BC are congruent. So if I look at some of these examples, if I look at example 1, there is one teeny tiny typo. This 6 here means the whole thing is 6. So notice this is a let's do this in highlighter. This is a radius, and this is a chord. The radius is perpendicular to my blue chord, which means my chord is bisected. So that's 3 and that's 3. So x is 6 because this chord and this chord are both perpendicular and they're both the same distance away from the center, so you know they're congruent. So it's 6. If I look at this next one, let's see if we can figure it out. So I know that this chord is perpendicular to this radius. So that means that both of these little pieces are 14, which means this whole thing is 28. So now if I look at the other chord, it's congruent. So since it's congruent, I know my center is equidistant to both. So x is 12. Number 3 is a challenge problem. I want you to pause this video and see if you can figure out how to solve this problem. My hint is I would try to make a triangle and see if you can figure it out. So if I go through and I explain this, I know this right here is a radius, yes? And if I move that radius to make a triangle, I can move that radius right here. Now I have a triangle, right? And notice radiuses are all congruent, so that's x. So now notice I have a right triangle. So one side's 3.6, one side's x. How do I find this side here? Well, since that chord is perpendicular to the radius, you know it's bisected, so that's 4 and that's 4. So now I'm going to use this right triangle, and I'm going to do 4 squared plus 3.6 squared equals x squared. So when I go ahead and I type all that in my calculator and I square root it, I get x equals 5.4. So a friendly little tip for yourself is whenever you have a right angle, try to make a right triangle. Whenever you get stumped and you don't know what to do and you see a right angle, ask yourself, okay, fine, well, could I make a right triangle and see if you could go from there? So I want you to pause this video and I want you to try 4, 5, and 6 on your own and then unpause the video and I will have the answers on the screen. So I put the answers of 4 and 5 on the screen, but I actually want to go over number 6. So the answer to number 6 is 9.8. And how I got this is, well, whenever you get stumped, I told you look for a right triangle. So I see this right triangle right here. So I know that I have both the legs, but I have to find the hypotenuse in order to be able to solve it. So notice that this length right here, my hypotenuse, is the radius of the bigger circle. So if the radius of the little circle is 5, what's the radius of the big circle? Well, it's 11. Because 5 plus 6 make 11. So now I'm ready to rumble. I have 5 squared plus x squared equals 11 squared. Solve for x. X is 9.8.